Welcome to lecture 12. It is the last one in the series lecture. A simple attempt through machine learning predicts the first repair life 79 of teaming ladle through valuable different input from both refractory and steel unit data. However, such effort is insufficient and modified machine learning with more data points is in progress to fix maintenance and refractory lining schedules without any disaster. This is a complete effort by BTech scholars. Thank you to all of them. The target is to predict the life of the slack zone to maintain and keep a healthy ladle. Low to high data set modeling by machine learning. Annually, the world produces approximately more than 150 million tons of steel. However, occasional breakdowns of ladles can result in unavoidable situations that lead to production delays. Our goal is to develop a predictive model that can provide insights into the average lifespan of a ladle, allowing us to schedule maintenance and prevent any potential mishaps. A simple protocol can be adapted to start such exercises. Factors, that means parameters, affecting the lifespan of the slack zone of the steel ladle need to be identified. Herein, we started with 11 such parameters like slack basicity, operating temperature, CCS, density, porosity, coke porosity, PLC, raw material purity, magnesia crystallite size, modulus of elasticity and modulus of rupture. All data along with lifespan was collected from particular refractory and steel industries and stored in CSV format. The machine learning process was executed using Python programming in Google Colab, an online machine learning notebook. Machine learning libraries such as Pandas, Scikit, Learn and NumPy were also used in this process. Slack zone lifespan data in CSV format was loaded using the Pandas library and cleaned the data. Machine learning algorithm named random forest regressor was trained on the data. After being trained, the algorithm was validated by additional data points. Training prepares the algorithm for the application in predicting the lifespan of the slack zone lining of the steel ladle refractory. While the program is ready, a user can input the value of different parameters affecting the lifespan of the slack zone refractory, and the program gives the lifespan of the slack zone as the point. Although the actual scenario is not so simple, it demands more exercise. Considering the above protocols, we collected data from the refractory manufacturing unit and steel sector, where they used all those bricks in the slack zone. Data collection is one of the most important steps in machine learning. Sufficient data is required to prevent the problem of overfitting. In this work, we picked up data from the perspective of operational data from steel industry and refractory properties. These 9, green box and cyan box, these 2. Although we need to update and consider more operational parameters, and we will do later. The cyan box indicates 2 operational parameters, slack basicity and steel process temperature. In apparent, these are not enough. Later, we are on the way to considering other processing parameters. The green box indicates the data from the refractory unit. In actually, the selection and availability of honest data is a serious concern to predict and develop a model. For example, getting MgO crystal size in micron. For all batches is difficult. So, we will delete that data in the future model. A total of 150 data points are collected in the beginning. It is sloth and low data points we have to modify. Make sure data is free from missing or incorrect values because they can affect the prediction to a great extent. Make sure that data should also be free from bias. Random forest algorithm is highly accurate and takes less time in the training process. Random forest regression algorithm is a collection of different decision tree algorithms. Decision tree algorithms are powerful machine learning algorithms capable of making predictions and being trained on complex data sets. So, herein we used this random forest model. Each decision tree makes its prediction and the final prediction is the mean prediction of the individual decisions made by individual decision trees. It is a collection of 100 to 500 individual decision tree algorithms. Here number of decision trees 50, 500. Since the prediction is the mean of the predictions made by many individual algorithms, it is very accurate compared to other algorithms. Herein the start and end of the Python code have been shown. I believe there is enormous scope to develop a program for hard code sectors. Python program takes slag basicity, operating temperature, CCS, density, porosity, coke porosity, PLC, raw material purity, crystallite size, MOE and MOR as input from the user. It gives the output lifespan of the slag zone of the steel ladle. This is the input, this is the life. For example, the lifespan of the slag zone 79 hits. This is the first repairing during input data set like this. But this is a very simple model with low data points and thus further development with defined input parameters and data points are considered for the next course of action. Performance depends on refractory properties and steel operating conditions. Thus, input parameters have been considered from both perspectives. Certain parameters were eliminated and are added because of the data and model accuracy. 8 input parameters from the refractory processing unit and 8 related to steel processing unit are considered to cover complexity and get an accurate model. Color signifies the MgO brick heated up during molten steel production and all are contemporary to each other. The resultant performance and life depends on proper synchronization of all data points. Systematic data can only be obtained with a systematic record for each batch. It may be either refractory or steel. Shewhart chart assists in monitoring a process while any process follows upper control limit and lower control limit that eventually help us to get unbiased data. Moreover, a quality record in the form of Shewhart chart will give the customer a sense of confidence. At the same time, quality data assists in data analysis for prediction. It also informs producer about the tendency for quality to diminish, probably the cause minor change in raw material or in occasional lack of temperature control. These are the accountability of refractory unit. Certain parameters also need to be monitored during steel processing, for example, arcing time, total holding time, etc. These are the accountability of steel unit. We are developing a model through 1 year of data, including performance for all seasons. Here these are the upper limit, this is the lower limit, and this is the variation with respect to different month. And if we keep the data continuous manner for the entire season, we can get the unbiased data and it may predict the exact model. A typical workflow for current state of art is shown in this slide. Let me take you through our machine learning workflow step by step. It all began with the exhaustive gathering of our data set, meticulously assembling a comprehensive collection of data points crucial for our analysis. With the data in hand, we moved on the critical stage of data retrieval, ensuring the accuracy and completeness of our data set. The subsequent phase involved careful and precise data processing and wrangling, where we dedicated ourselves to organize the data systematically, making it ready for the following stages. Harnessing our expertise, we will focus on data extraction and engineering, strategically identifying and incorporating key parameters for our predictive model. Our process continued with meticulous feature scaling and selection, a crucial step to ensure that our model would be equipped with the most relevant and influential features important for accurate predictions. Employing sophisticated machine learning algorithms, we delved into the intricate task of modeling, crafting a robust and reliable predictive system capable of estimating the lifespans of steel ladles with precision. This process was followed by an extensive model evaluation and tuning process, where we rigorously tested and refined the model, repeatedly iterating until we achieved a level of performance that met our stringent standards. Making a web app, how it works. Imagine your web app as a house. Users are the guests who visit your house. The front part of the house, built with HTML and CSS, is what guests see first. Think of it as the design of a house and structure. Adding JavaScript is like making the house interactive and lively for the guests. Now the web server is like the butler who takes requests from the guests and bring data back what they need. A big storage room inside the house called the database. In the case, it's my SQL, where you keep all the essential things guests might need later. Behind the scenes, you have the brain of the house, the backend. It handles all the important tasks like processing information and ensuring everything runs smoothly. Think of the file system as the cabinet, where you keep all the necessary files for the house to function properly. Understanding this setup can help us build a sturdy and user-friendly house, a web application that works well for everyone. Eventually, systematic user-friendly data input will provide the live prediction of slack zone bricks. In one sentence, if you put the data, that means we consider 16 input, then we can predict the life of the steel ladle, and similar thought process can be implemented for other vessels as well. I appreciate your patience. Thank you. Thank you all for your participation.